Back in 2017, astronomers spotted something they had never seen before: a long, cigar-shaped object racing through our solar system on a one-way hyperbolic path. They named it Oumuamua, a Hawaiian word meaning a messenger from afar arriving first. But it wasn't just the shape that puzzled scientists, it was what this visitor didn't do. It had no icy tail like a comet, no heat trail and no outgassing, even when it passed dangerously close to the sun. Stranger still, as it moved away from the sun, it suddenly sped up, without any visible propulsion, no jets, no fuel, nothing. It came from another star system, moved like nothing we've seen before, and left behind a storm of questions. Fast forward to 2025, and a new wave of analysis is offering fresh insight, and not the comforting kind. Using cutting-edge tools and quantum-enhanced optical modeling, scientists, including Michio Kaku's team, uncovered something deeply unsettling. This object may have behaved in ways that no natural body ever could. When Oumuamua accelerated, it didn't do so randomly. The motion was exact, controlled, and strangely elegant. Every time it completed a 7.3-hour rotation, its speed adjusted just enough to keep it on track. That kind of coordination doesn't happen in comets or asteroids. Space rocks don't make mid-course corrections. Nature doesn't self-steer. And yet, this one did. The data revealed micro-adjustments in its speed that matched its shifting orientation to the sun. In other words, it behaved exactly like a light sail, a theoretical propulsion system where radiation from a star gently pushes a reflective surface across space. But not just any light sail, one with adaptive geometry, meaning it could subtly alter how it reflects light depending on its position. That kind of tech isn't just rare, it's non-existent on Earth. We've imagined it in theory, but nature certainly doesn't build it. So what does that mean? It means this object may not have been drifting aimlessly through space. It may have been navigating. With a precision far beyond our current engineering, Oumuamua seemed to know how to ride the solar wind like a ship catching the breeze. This led Michio Kaku and a growing number of scientists to a startling possibility. Oumuamua might not be a natural object at all. It might be something else entirely, a probe, a messenger, or a relic of advanced technology from another civilization. And the story doesn't stop with how it moved. The next twist? Its origin. Thanks to new data from the European Space Agency's Gaia spacecraft, which has mapped nearly 2 billion stars with stunning precision, researchers have retraced Oumuamua's path. What they found is chilling. Its trajectory leads back to a quiet, empty region of space. No stars powerful enough to eject it. No violent forces to explain how it got flung into interstellar travel. In other words, it didn't get thrown from somewhere. It may have been launched, and if that's true, then the universe might be far more active and far more aware of us than we ever imagined. When scientists traced Oumuamua's path backward through space using the most detailed star maps we've ever created, they stumbled upon something that flipped conventional astrophysics on its head. The object didn't come from a place full of chaotic gravitational activity like we'd expect. It emerged from a quiet, still patch of space known as the local standard of rest. But more specifically, it came from a part of it that seems dead. A region with none of the usual suspects that could naturally sling objects into deep space. Here's why that's so weird. To reach the speeds Oumuamua was traveling at, an object would normally need help. Intense gravitational kicks from binary stars, explosive outbursts from supernova, or radiation blasts from massive stars. That's how space usually ejects things. But when scientists looked at this object's supposed origin, they found none of that. No twin star systems within 10 light years. No giant stars throwing off material. No recent supernova activity. No dense star clusters to generate chaotic gravitational slingshots. In fact, this area is eerily calm. A cosmic no man's land where everything should just stay put. There's simply no known natural force that could have launched Oumuamua from there at interstellar speeds. The data from the European Space Agency is very clear. This thing came from a region where objects aren't supposed to leave. And that raises a chilling possibility. What if it didn't just happen to drift out of that dead zone? What if it was placed there? A silent launch from a quiet corner of space, far away from the kind of cosmic activity that might tip off anyone watching. If someone, or something, wanted to send a probe through the galaxy without drawing attention, this would be the perfect starting point. It's an idea that's now gaining traction. Oumuamua may not have been just a wandering rock. It may have been launched with intent, but it doesn't stop there. The object's spin, once thought to be a clumsy tumble, now appears to be something else entirely. In March 2025, scientists ran the full light curve data through cutting-edge AI, trained to detect patterns hidden deep within complex signals. What it found was stunning. What looked like chaotic spinning was actually a precise and intentional rhythm. First, the main rotation cycle clocks in at exactly 7.3 hours, with a consistency that varies by less than 0.002%. That kind of precision is unheard of in natural objects flying through space for millions of years. Then, every 43.8 minutes, tiny adjustments occur, micro-rotations that subtly shift the object's surface toward the sun. Most astonishing of all, this pattern creates a scanning motion, as if the object was actively surveying space as it traveled through our solar system. When aerospace engineers saw this data, it rang a bell. These patterns are almost identical to those used in advanced spacecraft designs. Controlled spins like this help balance temperatures, aim sensors, and ensure solar energy is collected evenly. Oumuamua's rotation wasn't random, it was optimized. If it was artificial, that spin would serve at least three purposes: harvesting solar energy as it glides between stars, scanning its environment in all directions, regulating heat to avoid damage from intense sunlight. In short, this object wasn't just passing through, it may have been watching, collecting, and communicating. What does this all mean? That's up to you to decide. Drop your theories in the comments. And if you're as curious as we are about what's out there, don't forget to subscribe and hit that notification bell. Because if Oumuamua was a messenger, it might not be the last. If this new discovery holds up, it could mean Oumuamua wasn't just drifting through space, it was actively tuning itself as it moved through our solar system. It might have been absorbing energy, sending out signals, or even scanning Earth and nearby planets. What makes this truly wild is that the pattern wasn't something we caught right away. It only surfaced after advanced AI systems dug through the entire dataset, pointing to a deliberate design that masked intention behind the illusion of randomness. And that changes everything. If Oumuamua's rotation is programmed, then we're not dealing with a random piece of space junk. We're looking at something built with purpose, something intelligent, mind-blowing, right? If this gives you goosebumps too, hit subscribe and tap that notification bell. We've got more revelations coming about Oumuamua and the cosmic secrets that mainstream science rarely talks about. But one of the most baffling clues surrounding Oumuamua, and the one that has scientists truly scratching their heads, is what they now call the thermal signature paradox. Everything in space gives off heat. It's basic physics. So when NASA's Spitzer Space Telescope locked its sensitive infrared eyes on Oumuamua back in November 2017, shortly after it had passed closer to the Sun than Mercury, astronomers expected a clear heat signal. Instead, they got nothing. At that distance, Oumuamua should have been sizzling at over 500 degrees Celsius, but there was no infrared glow, no thermal emission, as if it had absorbed the Sun's energy, and then just vanished it. Fast forward to 2025, and now, thanks to cutting-edge thermal imaging algorithms, the mystery deepens. The new analysis confirms it. Oumuamua absorbed heat, but didn't radiate it back like every other object we've ever studied. That's not just weird, it's physically impossible under known laws of thermodynamics. Even the darkest asteroids and dead comets heat up and glow in infrared when they get near the Sun. Take interstellar comet Borisov, for example. When it flew by in 2019, its heat signature was clear and predictable. That's what science expects, but Oumuamua absolutely nothing, despite being closer to the sun. So how could it stay so cold? There are only a few possible answers, and each one is more disturbing than the last. It might be made from some exotic material we've never seen before, something that traps heat like a perfect insulator, not found in nature, not on any known asteroid or comet. It could be using metamaterials, engineered substances that bend and block heat and light in ways we can only simulate in labs. NASA's dabbled in this tech, but only in theory, and nowhere near the level needed to make an object vanish in infrared. And then there's the most chilling possibility: intentional thermal cloaking, a technology designed to hide it from being detected at all, like an invisibility suit for space heat. Here's the kicker: this idea isn't science fiction. NASA has actually explored stealth tech for future probes, reflective shields, thermal dampening aerogels, even smart coatings. But none of them come close to completely eliminating a thermal trail the way Oumuamua seems to. Which leads to a darker question. What if we weren't supposed to see it at all? What if its path just happened to bring it unusually close to Earth, and we accidentally spotted something that's usually invisible? And if this one got caught, how many others have slipped by unnoticed? That's why this mystery isn't just fascinating, it's deeply unsettling. It seems like someone designed Oumuamua to bypass detection altogether. And the more we learn, the more it points to something beyond nature. The strange silence of its heat signature, the precise tumbling motion, the unexplained acceleration, they all fit together in a way that nature doesn't typically work. Now, leading scientists like Michio Kaku and Harvard's Avi Loeb are shifting their focus. In April 2025, Kaku published a groundbreaking paper suggesting Oumuamua might not be a working spacecraft at all, but a technological relic, the leftover shell of something that once had a mission, not a flying saucer, not a probe, but the fossil of an ancient piece of alien technology. And the evidence supporting that idea? Well, it's only getting stronger. Let's start with its shape, because Oumuamua isn't just weird looking, it's unlike anything we've ever seen in nature. Imagine an object nearly 400 meters long, but only 40 meters wide. That's a ratio eerily similar to components we use in space tech, like long-range communication arrays or fragments of damaged light sails. It doesn't look like a comet or an asteroid. It looks engineered. Then there's the way it moves. Oumuamua spins in a strange tumbling pattern. Not entirely random, but not fully controlled either. It's the kind of motion you'd expect if a spacecraft's internal guidance system had broken down, like a gyroscope that still remembers how it was supposed to behave, even as its parts slowly fall out of sync. And this isn't guesswork. An AI system recently detected repeating purposeful patterns in that tumble. Next comes the silence. Despite passing close to Earth, Oumuamua didn't emit any signals. No beacons, no data streams, no transmissions of any kind. If it were a working probe, you might expect some kind of communication. But what we got was complete radio silence, and yet it still displayed traits that scream artificial origin. These strange clues have led scientists to connect the dots with what's known as the litter hypothesis, a bold theory about the universe and the Fermi paradox. In simple terms, it suggests this: maybe the first proof we get of extraterrestrial intelligence won't be flashy. No dramatic signals, no glowing spacecraft. Instead, it could be their trash, the leftover pieces of old probes floating aimlessly through the stars, forgotten, broken, but still out there. And that's what makes Oumuamua's case so compelling, and a little bit sobering. We've always imagined first contact as a grand encounter, but what if it's more like discovering a ghost ship? What if this strange visitor wasn't meant to be found at all? Here's where things get even stranger, and far more unsettling. Physicist Michio Kaku has raised a chilling possibility. What if Oumuamua wasn't space junk, but a sensor that already finished its job? Picture this. An advanced civilization seeds the galaxy with thousands of small, quiet probes. They drift from star to star, gathering data without drawing attention. When they pass a solar system like ours, They observe, record, and move on. Silent, invisible, unnoticed. That's exactly the kind of path Oumuamua followed. It zipped through the heart of our solar system, close enough to scan the planets, especially Earth, but far enough to avoid being easily tracked or caught. Its sudden acceleration away from the Sun? That might have been the signal that its mission here was complete. If this is true, then it means something was watching us, and we never knew it. That's why Kaku calls this the passive probe theory, and he believes it's one of the most plausible explanations for Oumuamua's bizarre behavior. The updated 2025 data backs him up. First, the object's route through our solar system followed what military analysts would call an optimal surveillance trajectory. It glided through zones where it could gather maximum intelligence on our technology, atmosphere, and electromagnetic activity, all while staying just out of reach. Second, its mysterious physical traits no longer seem random. The heat invisibility, the unusual motion, the silent glide, they now look like carefully selected features designed to reduce detection and maximize stealth. And third, perhaps most intriguing, the new position data shows that Oumuamua lingered in a perfect listening zone during its closest approach to Earth. For about 72 hours, it was ideally placed to capture our strongest outgoing signals. TV broadcasts, satellite data, internet traffic, a full snapshot of humanity in real time. So here's the big question. What if Oumuamua wasn't just passing through? What if it already scanned us, studied us, and transmitted its findings back across the stars? And we only spotted it after the job was done. That's the possibility scientists like Kaku are starting to seriously consider. Not just that we're not alone, but that whoever they are, they might already know all about us. This quiet, hands-off method of observation lines up perfectly with how any advanced civilization might conduct deep space reconnaissance. After all, an active probe, one that beams signals or gets too close to a planet, risks being seen, intercepted, or even attacked. A passive observer, on the other hand, it stays under the radar, gathers what it needs, and slips away unnoticed. So what would such a silent scout be looking for? With the right tools, it could do a lot more than just float by. A probe like this could use high-resolution spectrography to scan our atmosphere, detecting signs of life, industrial pollution, or even radiation from nuclear activity. It could read our electromagnetic footprint to gauge our technological growth, radio waves, satellite transmissions, internet traffic, all of it painting a picture of how advanced we've become. It might even sample our communication patterns to understand our languages, cultural dynamics, and social structure. And more practically, it could map the Earth's resources, our water, minerals, energy grids, to evaluate whether our planet holds strategic value. This isn't science fiction, it's basic logic applied on a cosmic scale. Physicist Michio Kaku has warned why this idea should concern us. In human history, peaceful reconnaissance often gave way to something more direct, and not always with peaceful outcomes. First comes observation, then potentially contact, or worse, intervention. If Oumuamua was indeed a passive surveillance probe, then it's already sent back everything it learned. It may have captured detailed insights into our global systems, our defenses, vulnerabilities, and divisions, and transmitted all of it back to wherever it came from. Think about that for a moment. We've been studied by a civilization far more advanced than ours, and we didn't even realize it. And here's the part that really unsettles scientists. We only spotted Oumuamua by pure luck, which raises a much bigger question: how many others have passed through unnoticed? New analysis from 2025 brings this into sharper focus. Statistically, based on our current tech and how we happen to detect Oumuamua, astronomers now estimate that objects like it pass through our solar system about once every year. Not occasionally, yearly, but we're blind to most of them. Here's why. These objects only become visible for a tiny window, maybe 5 to 10 days, during their closest flyby. And even then, we only have the equipment to watch about 15% of the sky at the depth needed to catch them. Many approach from awkward angles hidden by the glare of the sun. Others, like Oumuamua, seem to have a built-in cloak, reflecting no heat, leaving no trace. In short, we're being visited more often than we realize. But our tools are so limited, we're probably missing nearly all of them. And that's the real revelation from the Oumuamua story. It's not just about what this one object was, it's what its presence suggests. That Earth may already be part of a larger cosmic observation network. That intelligent life has not only found us, but may have been watching us for longer than we ever imagined. And we're only just waking up to the possibility. The Vera Rubin Observatory, set to go fully operational by late 2025, could completely change the way we watch the skies. With its massive 8.4-meter mirror and a jaw-dropping 3,200 megapixel camera, this observatory will scan the entire visible sky every 3 nights. That means we'll finally have the power to detect fast-moving interstellar visitors like Oumuamua, weeks or even months before they slip past the inner solar system. And that kind of early warning changes everything. Why? Because it gives us a shot, not just to observe, but to intercept. That's exactly what Project Lyra has in mind. Proposed by the Initiative for Interstellar Studies, this daring mission plan involves slingshotting a spacecraft around Jupiter, then firing it toward the Sun to perform a powerful Oberth maneuver, a way to gain insane speed by firing engines at the deepest part of a gravity well. With this strategy, speeds of up to 70 kilometers per second become theoretically possible. That's fast enough to chase down objects like Oumuamua. It wouldn't be easy. A mission like this would need to launch within 6 months of detection and require cutting-edge propulsion, possibly nuclear thermal engines or next-gen solar electric drives. We're talking about a delta-V demand 5 to 6 times greater than a mission to Mars. But if pulled off, we could reach one of these mystery objects in just 2 to 3 years. That's the exciting part. But now comes the chilling part. If Oumuamua really was an artificial craft, some kind of scout or probe, then we may have only witnessed the beginning. Because in every historical scenario, reconnaissance tends to be followed by something else, something closer. A growing number of researchers, including Michio Kaku, are sounding the alarm. The frequency of these interstellar visitors is starting to look like more than coincidence. If they're artificial, this could be part of a massive galactic mapping project. Like someone, or something, is systematically scanning every solar system it passes. And next time, the visitor may not just fly by. It could slow down, it could enter orbit, it might even make contact. And if it does, we're not in a position to defend ourselves, especially against a civilization capable of the kind of tech we suspect was involved in Oumuamua's flight. Let's not forget, the 2025 reanalysis revealed something no natural object should be able to do. Oumuamua didn't just drift, it accelerated as it exited the solar system. But not randomly, it did so with precision. The acceleration was finely tuned to offset its tumbling motion, following a mathematical pattern consistent with intelligent design. This wasn't gravity at play, and it wasn't propulsion as we know it. The curve of acceleration matches exactly what we'd expect from a highly advanced light sail, a method of space travel that uses radiation pressure from stars for thrust. But this wasn't any light sail we've designed. This was something far beyond our current capabilities. The implications are enormous. This isn't science fiction, it's real data, processed using the most powerful AI models and observational tools on the planet. It doesn't just hint at alien technology, it screams it. And as we move into a future where more of these objects may be spotted, intercepted, or even approached, we must ask ourselves a difficult question. Are we ready for what comes next? Because they already know we're here. And if they choose to return, it won't be by accident. Oumuamua didn't come from where you'd expect. According to the European Space Agency's Gaia mission data, its path leads back to a quiet patch of space, a stellar dead zone. No powerful stars, no chaotic binary systems, no supernovas that could fling debris out at such high speeds. In short, it's a region where no natural object should have reached interstellar velocity. And yet, That's exactly where this mysterious visitor came from. That silence is suspicious, because if you wanted to launch something into deep space without raising red flags, this kind of low-profile origin point would be perfect. Now here's where things get even stranger. When Oumuamua cruised past our sun, closer than Mercury, it should have been roasting. Objects that close normally glow in infrared, giving off heat picked up by telescopes like NASA's Spitzer. But this one? It didn't radiate anything. The updated 2025 analysis, using advanced thermal algorithms, confirmed what still sounds impossible. It absorbed sunlight but didn't release any heat. That's not just weird. It breaks the known rules of physics. This kind of thermal invisibility is exactly what scientists theorize advanced stealth technology would look like, especially if you were trying to avoid being noticed by infrared sensors. Its spin was just as peculiar. Instead of wobbling like a tumbling rock, Oumuamua rotated with precision. A nearly flawless 7.3-hour rotation with microscopic variance, less than 0.002%. That level of consistency suggests purpose, not randomness. In fact, AI modeling now shows this spin pattern would be perfect for scanning planetary systems or collecting energy while in transit. And then there's the shape. This wasn't your typical asteroid. At about 400 meters long and only 40 meters wide, its proportions are way outside the norm for natural objects. It was shiny too, highly reflective, and it sped up in a way that defies gravity and solar pressure alone. That unexpected acceleration, along with its peculiar form, strongly points to a technological origin. Not a rock, not a comet, but something built, possibly long ago by someone we've never met. Physicists like Michio Kaku and Avi Loeb now believe it carried what they call a technological signature, in other words, evidence of design. But just as suddenly as it arrived, Oumuamua was gone, out of our reach, flying along a hyperbolic path that ensures it will never return. We had mere days to observe it, and we weren't ready. Not even close. And now we're left with haunting questions. If it was here to study us, we'll never know what it learned about our world, our capabilities, or how we treat each other. And even more unsettling, we don't know who it may have shared that information with. Kaku puts it bluntly, Oumuamua may have been our first brush with alien technology, but if the probabilities are right, it definitely won't be our last. For those needing a refresher on the facts, Oumuamua was discovered on October 19, 2017 by the Pan-STARRS telescope in Hawaii. Its name means a messenger from afar arriving first, and that name might turn out to be more prophetic than we realized. Measuring about 400 meters long and 40 meters wide, its cigar or pancake-like shape is unlike anything else we've ever seen in our skies. Whatever it was, it left us with more questions than answers, and a sense that next time we should be paying much closer attention.